How's it going, everyone? Welcome. Eulier Gonzalez. And today I want to explore now this topic, especially when it comes to the concern about enclosing variables inside of a scope. And not only that, but also is that by describing these tools that we have in JavaScript and also in any programming language, right? Which is scope and variables, right? You can think of this like a screwdriver, like a screwdriver and a nail and a hammer, right? So you have all of these particular tools, and in our case with JavaScript, we do have is the scope, all right? You can think of this like a box, sandbox, where you can put all of this stuff, all of your toys that you would like to, all right? And also we have is now variables, right? And you can think of variables like, hey, things that you can put inside of this scope, right? Any tool or anything that you can imagine that you can put inside of this box, sandbox. So this particularly analogy of how we can think here is quite useful because in this particular sandbox, there are things that you can do and cooperate, right? Uh, so another good analogy of this is like an elevator, all right, or like a building. So in each one of those particularly floors, you can now put stuff. So for example, it's like you can now put in this stuff that you put are, for example, variables, right? And these variables can represent is any particular value, right? That value can represent is something in the real world, all right? It can represent is now like a lighter, like a switch on and off. It can represent now a particular number on the floor. It can represent now a string that describe is what this floor is doing. It also can represent is if there is something in this particular floor or not, or perhaps describing is more complex stuff in this building using, for example, objects. Hey, this is a chair. Hey, this is a ticket. Hey, this is a desk. Hey, this is a paperwork, so on and so forth, right? So this understanding of working with variables and scope and understanding that, especially in JavaScript, is important because if you're going to dedicate your time and attention to the web, which I definitely I am grateful for all the hard work and time, sweat, and sometimes blood in putting their fanny for long hours in a desk to figuring out how to make this work, especially the computers and how you can now compute in a decentralized way. Uh, and how you can now have some way to share that data and so on so on and so forth. So I do find that this is one of the great things that I love or that I appreciate that that I was blessed to be exposed to this because no other people has the opportunity to do so, and I was reluctant to kind of going into this, especially because I hear too much to the society voices out there, and that you shouldn't do this, you should do this. This is how looks like. So, for example, is that hey, if you're going to be a software engineer or anything that anyone that work with computer, you should be somebody that is fat or this or that, you know. But it turns out that all of those are just based on the norm, based on statistics, based on demographics, based on culture, based on things that live in concepts but not in your own reality. And by that I mean is that your day-to-day life experience. So this is also combining is the uh, psychology and philosophy, not in the sense of something that is conceptually or some intellectual ideas, is because you you and I have this skin of the game, right? And so, in any case, because of that, right? And then I want to and then I want to ease my pain anytime that I'm going to work with uh, anything related to computers, right? So I do want to understand what is the nuance of working with these computers in order to design software, in order to build applications, in order to maintain those applications. And in the meantime, well, I'm going to receive in a compensation from that. So here we are, right? So first thing first, I'm gonna make a quick recap of how do we get here, especially with the list exposure. Tiki tiki, that's right. You got it. Come on, where is it? This is the list exposure, all right? From this chapter 6, whose author is Kyle Simpson, a software engineer that has over 20 years of experience. And then this is the second version of this book, the You Don't Know GS Yet series. So here in the scope, I was very reluctant to actually dive deep into this. First, because we always the hard part of doing anything is the initial one, the doing. But in any case, it's not hard. It's because your mind still think that it's hard. So in any case, and I do agree when people say that do it with fear, with happiness, whatever it is, because your mind is sometimes not yours. In any case, your mind is the society, your mind is the outside world. So in any case, here with the scope, we look at the why is important to understand about the scope, all right? And the thing here is that because JavaScript behave like a compiled language, where this compiled language have is these three phases. The tokenizer, where it's going to transform all of this source text into meaningful tokens to the language, and then the parsing, which transform these strings of tokens into now a structure that it can understand by the machine and by humans as an abstract syntax tree. All right. And then once you have this instruction, when you have this structure, right? Generally, it's going to now is generate the code. It's code generation. Why is important here? Because JavaScript initially was a script, so it is a scripted language, aka it's going to evaluate line by line your code, all right, as an interpreter language. But it turns out that when you look at the observable reality of how JavaScript behave, you then now identify a couple of things. One is that sometimes there now is evaluate errors early before the execution. So for example is syntax errors, early errors, and hoisting. So because this hoisting is a concept of how now certain variables are putting at the top of the scope, all right, and this is certain declarations, which is variables, functions, and also other hostable declarations such as uh, async functions, generator, classes, and let and cons. All right. So in order to understand now how this scope works, we look at that anytime that you put now any of these declarations, they will be hosted. And the question is, so we look only is to var, let, cons, and functions declarations. So for example, if you do have now a function here, all right, where you say, hey, I would like to define now is some sort of class definition. Say class definition here. Say user. So it's gonna call this like a game, right? Call this game. And here you have now your user, all right. And this user will have now a constructor that you're gonna pass now the name, right? And then you want to assign this dot name to the name, something that we also look at later on this score. What is this value is? The TLDR is that this is a feature from functions that allows to access is the execution context at runtime. In other words, it allows us to access is this particular objects that when the function is being executed, or in this case, when this class is executed, now we do have is the data available for that. So, for example, here you can say, hey, I do want to know is what is the user in this moment, right? What is the user at this moment? You can also define some another function here to say, hey, or particularly here to say, hey, print name, and this print name is going to return is this dot name, right? So, but I do want is to know is how this will behave, especially with game and using now functions as it is, right? It say, hey, cannot access user before initialization, which means this also behaves the same as the lexical here. So for example, if you put now this, you replace this and you say, hey, let's say let, but in this case with this, but in this case with this, again, you say, hey, user here will be now is earlier, all right? And if you call that, it will also give you now the same kind of error as a reference error, right? So why am I mentioning this? So, and if also if we change now var here, it will now give it this as undefined. So why am I mentioning this? First, in the case of a scope, is that now there are certain syntax forms that allow us is to enclose is variables or certain definitions that only works here. Okay, and we're gonna see why we want to do that, right? But at least we have is this function declaration like block, or this declaration that allows to define is a scope, and we can actually is take a look at that. All right. For example, is on the scope. This website is very slow, and I don't know why. There might be some very. Let me take a look at the scope here, right? The standard define. No, but this is the scope of the programming scope analysis. This is what I'm looking for. right? What this is describing is now this analysis of this scope, this syntax operator here. So, but again, and anytime that you read this syntax directed operation, is that there are now algorithms that are associated with one of more definitions in the language, or this particularly reserved keywords. So those reserved keywords, for example, like blog and like functions, they actually create this, right? So as we read this, bound name second. So again, the whole point of today's video is just to make a quick recap of this, all right? To see that what is doing this scope analysis, and they say, hey, this is a syntax directed operation, bound names and takes no arguments and return a list of a string. The question is that what is this syntax operations? You know, what is the form of the syntax operation? It is defined piecewise over the following productions. So this scope analysis, it'll work is for binding identifiers, yield, await, let and cons, also bounding names, variables declaration, object bindings, so array binding patterns, binding property as a list, as an element, as for declaration that create also is particularly a scope, the functions, and the formal parameter as well, which means that inside of this, similar for generators, async generator, class, and so on, and import and name import, as well as the exports and the declarations. So this is the syntax static semantics declaration part, right? The question is, what I mentioned here is that this scope analysis is first is as you can see here with this static semantic, all of these kind of operations happens is before the code is executed. So the bound names happens before the code is executed. You may wonder, how do I know this? Because of this particular tag or description, static semantics. So it's describing is what happened is before the code is evaluated. All right. So it say, hey, I'm gonna bound names to the respective identifiers, and then I'm gonna look at the declaration part. Okay. So for example, hoistable declarations, whether it's functions, generator, async functions, class, and lexical declaration. So all of these are analyzed by the scope, all right, as well as is a constant declaration, lexical declarations, and lexical scope declarations. Here is telling you now how what is the analysis that this scope is going through. This variable declare names, variable scope declarations, top level lexically declare names, top level lexically scope declarations, and top level var declare names and scope declarations. But this is all of the scope analysis. So a good understanding of this is to say, hey, this is scope that happening is before our code is executed. Since the way how now this being is established, usually the part that are commonly in our that are part in our programs, okay, is by saying, hey, most of the time when you now look at the declaration part, a particular scope is gonna be so what it's telling here this is to say, hey, I'm going to now run a scope analysis when it comes to identifier is the name to this, to a particularly, or to the identifier, the names, to a particularly keyword, right? This is one of the scope analysis. The other is based on its declarations, okay? Based on which particularly declaration here, I'm going to now do another scope analysis. If this is a cons, I'm gonna do now if this is a cons, I'm gonna do is a if this is a cons, I'm gonna do that a scope analysis as well. If this is now a lexically declared name, all right, for example, in a block or in a case block or in a default, label statement identifiers, function statement list, class static block statement. So for example, function statement list as it is, and this function statement list, now we jump into another one, function statement list as it is going to perform now these early errors, function statement list, and the statement list, and the statement list, it can be either is statement list or a statement list, runtime semantic evaluation here of the block, for example. So again, I don't want to get it lost into the details because here we want us to be is much more effective and practical when to at least understand that when you read this doc, right? Anytime that you see this is telling that, hey, a scope analysis will be, so JavaScript or the ECMAScript 262 is going to perform now a analysis on bounding names, on declarations, if this is a constant, if this is part of a lexical declare names, all right, whether it's a block or a case block and so on and so forth. If this is not part of the statement, lexical scope declarations, even var declare names, scope and top level lexically declare names. So, in any case, this is scope analysis is something that is performed by JavaScript, and particularly, again, to make it much more meaningful in the sense of functions and blocks. Well, these functions and blocks actually allow us is to define is these variables as well as functions that it now behave in a certain way. So particularly with the block and with the functions, as we saw in previous videos, so certain identifiers, certain keywords, or as the ECMAScript like to mention, is that certain ECMAScript productions values, right? ECMAScript grammars, the production of ECMAScript grammars, certain declarations, all right? Now this is what it is, okay? This is how it's going to behave here. So block behave that actually is or this particularly blocks or scope, that it can be either functioned in blocks, it because you can now nest it this particular scope in order to know how one particular variable can have access to other or how a particular variable can be accessed by further nested scope. This particular questions works because now JavaScript internally in that particular scope has now a reference to the outer and you may wonder, how do I know that? That's a good question. Declarative environment records, object functions. So for example, here, okay, is describing is what this things is doing and what it has. So because anytime that you now create is a block, or anytime that you create now in a scope, all right, whether it's a block or a function, right? So JavaScript internally have now a property that has a reference to the outer scope via the outer env. So this environments records that, for example, when you use now a function, all right, is not only have these discrete values here or the bindings as well as the function objects, all right, but also it contains now is this function object that diggy function environment records. Let me see if I can get this. Here. Exactly, it's here. It's describing as this. So environments records, all right, it's like what are the things that are gonna have here. It's a specification that is used to define the association of identifiers to a specific variables and functions based upon a lexical nesting structure of ECMAScript code. So in other words, anytime that you, it's gonna keep reading, usually as an environment record is associated with some specific syntactic structure of ECMAScript code, such as functions declarations, block statement, or catch clause, or a try statement. So it's actually telling you that anytime that you have now a function declaration, a block statement, or a catch, all right, you will have now a environment records that allow you to now associate one identifiers, your names of the functions or the variables, to a specific variables and functions. And this can be now nested. Since this has this ability, okay, and each time such code is evaluated, a new environment record is created. So anytime that this functions declarations or block statement is evaluated, it's gonna create now these environment records. Okay, so it's created to record the identifier bindings that are created by the code. So every environment records, and here's when style is actually describing this. Each environment record has an outer env field, which is either null or a reference to the outer environment records. In other words, you can have now nested environment records, all right? Anytime that now this particular syntax or declarations are being executed. So for example, the functions block or catch of a try statement. Okay, so now things started to make a little bit much more sense. So the outer reference of an inner environment record is a reference to the outer record that logically surrounds the inner environment record. On an outer environment record may, of course, have its own outer environment record, and an environment record may serve as the outer environment for multiple inner environment records. Exactly. So an environment records may serve as outer environment for multiple inner environment records. So hey, this can be now. So this, to be more descriptive, is that say hey, this function that let me call it here the outer environment record, outer environment. Okay. By the time that it's called, it's going to create this environment record, all right, that allows to have is now the association of it is identifier to variables and functions. Okay, so it means that when you create now is another functions declarations, inner environment, right? You define is this environment here, all right, or even with a block as well, or even with a try and catch, right, like this. So all of this are now syntax that by the time that this is called is going to create now is going to create an environment record, all right, especially here is going to create now an environment record that internally they have now a reference to the outer environment, all right, and this environment in this outer environment also have now a reference to the outer environment, which is now the global, which is as you mentioned here, as we read here. So for example, if a function declaration contains two nested function declaration, then the environment record of each of the nested function will have as their outer environment record the environment record of the current evaluation of the surrounding functions. So environment records are purely specification mechanism and not need to correspond to any specific artifact to ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. So in other words, I can access to the outer environments, but internally this exists. Okay, so here we have now is the different environments record type that is being created. So it can be thought as that existent in a simple object-oriented hierarchy, okay, where environment record is the abstract class with three concrete subclasses. You have the declarative environment records, you have the object environment records, and the global environment records. So inside of the declarative environment record, you have is the function environment records and the model environment records are subclass of these declarative records. So this object environment record, it is used to define the effect of ECMAScript elements such as with statement, but this is something that we don't use, so no. It's actually is being deprecated. And the other is a global environment record, and it is used for script global declarations. It does not have an outer environment. It is outer environment is null. It may be pre-populated with the identifier binding and include an associating global objects here. So the internal methods or the abstract methods that this environment record has is this. It's going to associate the bindings. It's going to identify is the bindings. All right. It's going to create mutable bindings. It's going to create immutable bindings. Bindings that can be changed or not, initializing, set, then delete, check if this binding, if it has this binding, or it has super binding. I don't want to get lost into the detail here again, but what it means is that anytime, and this is also the reason why I'm actually pointing is into this specific topic, because it's described the reality of things like this, the environment records, until the identifiers. Ooh, sorry. The environment record and it is identifier, right? Is because of this. It's because is this describing is the nature of the block, the nature of the scope, the nature of its behaviors as well. And I want to do this because a lot of people actually love to repeat like parrots stuff from here and there and yada yada yada, and they don't even ever able to describe where the things coming from. So they're repeating it from the common sense, or from what they have heard from the society or from the community. But here is describing here. So now with this, right? And again, if you are in an job interview, and you're trying to tell this, and the interview somehow says, no, this is not, or it somehow is difficult in that interview, so you don't want to actually work with them. No. So in any case, so here's describing is the scope. Okay. By looking is at this, and well, there's some couple questions here, because the question is that, especially for JavaScript developer, is that how now the scopes are created, and how can we create now a scope, and also is what happens when we redeclare identifiers across different scope. So in this case, if you say, for example, hey, var, let's say is salute, right? And if you say, hey, var salute earlier, or you say, hey, hello, and then if you want to have access to this, like salute, all right, just to have access. And just to have access to salute, and just to have access to salute. All right. So what's going to do is that when we run this function, it's going to now execute this block, show what the salute has, and you might wonder, hey, well, it's supposed to print now hello, right? And in the catching, and in the try and catch, it's going to say no, it's going to throw nothing. So say, hey, you can is now throw an error, right? You say no. Okay. So what will happen when we run this code? What will happen is that a new environment record is created, okay? And this environment record has associated all of this, it contains now the association of the identifiers and its variables or functions, variables and functions, all right? Only that, and now this particularly var and function, they're gonna behave in a very specific way, specifically in JavaScript, right? So what happened here is that when we call this, say outer env, is gonna now print the hello, all right? And now throw is the console log with salute. It's gonna print hello twice. You got it. You're gonna print hello twice. And you say, hey, how is this happen? Why is this work, right? Why is that now is throwing you this, or is printed to this salute two times, all right? Well, it turns out that any time that it enter here, a new environment record is created, it create now this salute This is the identifier, and I'm going to bind that with this particularly keyword var, which will behave in a very specific way. And the same for functions in the inner env and console log and so on and so forth, right? So if you, for example, now do something like this, say this one, and then you say now is, hey, I do want to now evaluate is this, all right, and then I want to now call is inside of these inner functions, the inner env, all right. So when you call this, it's gonna now throw this 3 times here. So the first is because you throw now an error. The second is because now you are executing this code, all right. It's gonna create now this environment record, all right. That is now have a reference to the outer identifier, in this case here, salute, and also is going to look at this inner env identifier, because this inner env identifier doesn't live in this scope, all right. It's going to now look up the for this identifier, which now is registered here down below. But you might wonder how this is possible. Well, and it's because this particular behavior that functions and var has, and that is that known as hoisting. So all of this is just to now present a case to say that when we are using this specific syntax, now JavaScript is going to behave in this particular way. Okay, so at the end of the day, we also look at the particular scope. So let's going to wrap up with scope. So anytime that you define is a function or a block, or inside of even here in the try catch statement, you do catch that, all right. So it actually have access to this. Even here, when you now, instead of trying the catching here, you say something like this, all right, it will actually run this, execute that. But the thing is that what happened when you now, for example, redefine the same identifier here, and you say, hey, this is now salute, and salute here will be is hola, right? So if this is a block statement, what it's going to do is to say, hey, I'm going to now is say something like this. So now hola is going to be printed, all right. So now this is a scope here. But what happened when we put now, or when we try to make a reference before this, right? It's a no, I cannot here, I only bring is this twice, but it's interesting because here it doesn't throw any particular error here, all right. So it means that this try here doesn't behave as a, so this means that this doesn't behave now as a block here. You see, try doesn't behave now as a block here. Exactly. Try doesn't behave now as a block here. All right. And you may wonder, why is this? Well, because if you for some reason try to now here define is this, let salute to bonjour, say bonjour, or bon dia. Bon dia, I think is bon dia. Bon dia. Okay, like this, a bon dia, right? So what happened here is that this is going to throw now is a reference error here at this, right? And it's telling you, hey, in line 13 there is now an error because this is something that it cannot happen. This is now a particular behavior of this let and cons. And the other is, well, if this doesn't happen, all right, in a particular block, what will happen if you now, for example, is try to do the same here. So for example, like this. No. Okay, bon dia. All right. So for example, if you say now here, right? And you can say bon dia, and the other is comment va, ça va, ça va, but I don't have that. Ça va, ça va. Qu'est-ce que va? Ça va, exactly. Ça va? Ça va? It's not correct. It's ça va. My bad. It's ça va. All right. It's like say, hey, what's up? You know, ¿qué tal? ¿Cómo está la vaina? Ça va? Yes. So ça va here, and so here, all right. How this is gonna behave here? Well, because now var is because salute is now a var reference, you might have access to the hello because this is now a function block scope, not a block scope, and because they have the same name, what it's gonna do is to now have a reference to the outer var environment here, and then print that out, and no error will happen. But it turns out that, hey, it is the same as it is. So now salute here say no. Anytime that you have now an identifier, whether it's let, cons, in any scope, whether it is functions or block, that identifier cannot have access to this. This actually, we're gonna solve the mystery here. This actually solve the mystery here. This actually solve the mystery here. This actually solve the mystery here. Okay. So this is now to solve the mystery of scope in JavaScript, right? So far, so good. And also is that how we not only have is the block scope or function scope, but also we have is another implicit scope. For example, like the parameter scoping in a function. Another confusing topic is that what will happen when we redeclare identifiers in different scope, how they're going to behave, and especially how now JavaScript treat that, which is exactly what we look at this. This is known as shadowing. When variables with the same name are in the different nested scope, this is when shadowing occurs. And shadowing is this, all right, is that, well, JavaScript is going to now is take the value at that moment, all right? But it turns out that when you have a try and catch statement, it doesn't not only throw any error, but it doesn't allow to have access to this outer function here. You know, so try here is it's kind of weird here. It's kind of weird, especially when you have now shadowing variables here. You know, you can have access to that. So I'm just illustrating is this particular concept, and also why it is, and also the difference is between the function expressions and functions declarations, because especially with the arrow functions, the case is that we prefer to go with functions named, since now they are lexically available. We can know what is going on, is describing what it is, and also we can now is hosting those values. And in terms of and also before going into the hosting is the topic of, now that we know this particular scope of the function and the block and how they behave when we have now identifiers with the same name, all right, I also look at the other different scope. So for example, the global scope, and why the global scope exists, and why a scope actually, so what is the selling point of scope? And that is that it allows us to put all the things that we want to share amongst them. So for example, in this particular go, so we put all of the things that we want to share here, and make it that available in that particular scope. So because we have also another scope, so JavaScript depend on the environment in which JavaScript behave, we also have now other scope that expose or that have certain behaviors, all right? And again, the main case of the scope is that we have is this common place where we can share information, okay? And also this behave in the browser as, or in other words, the place of how we can now share is this common things, or so the global scope act now as this playground where we can now is cooperate here. We can put things to cooperate, and how that work is, well, if you use now is the ECMAScript models here to import now different models. This is the way how we can now collaborating is with different standalone files as an ex6 models. The other is that by enclosing that into a wrapper scope, usually a functions that allows to define all of these common models held inside of a variables, where we can describe is where we can collaborate amounts inside of this enclosing scope, aka the UMD, for example, right? And the last but not least is the global scope. So because depend of which place you are running JavaScript, is in the case of the browser, you have access to the global scope, all right, as well as some other internal functionalities. And now the global scope in this case behave quite particularly, because when you define declarations, when you define now this function declarations or variable declaration, these identifiers is going to be attached to the global variable, all right, at least in the browser. And also you can have access, for example, is and that is quite weird and I didn't know about it, but you can now, for example, have access is to you can interact now is with the DOM. via the window here, and by passing now is the ID of that particular element, you can actually is get that, right? And it's gonna give it to you is that. Say, hey, is this, right? Hey, I cherry pick this element here for you. This is a quite weird and odd behavior. Again, legacy behavior. Okay, this is a legacy behavior here. And I do find that this is quite interesting. Very, very, very interesting. You know, you can actually get all of these elements, the table, and so on and so forth. All right, good, good. And also, this is now to describe is the scope here, right? So what we can do with the scope and why we have a scope, what is the main selling point of a scope, and also that also this particular scope exposes certain JavaScript built-in methods, JavaScript primitive, native, global functions, namespaces like math, JSON, as well as just JavaScript friends like internationalization and WebAssembly. And also it hosts the particularly JavaScript specific engines here, or specific based by environment. So for example, console, the DOM with the window and the document, the timers, and the web platform APIs. So because we are now getting into this particular nuance of the global scope, right? The global scope is the window object, and how now these identifiers, when you use the var and function, will behave. They're going to be attached into the window objects, right? You can also do is global shadowing globals, all right? In other words, you can override those behaviors with let as it is. This might be a quite unintended consequence in the case of JavaScript or the browser here. You can also now interact with the DOM global objects, as we mentioned here. And also is you can now is name here. The other environment is now the web workers. So here you can have access to the DOM. It allows us to define some background task in the global objects, or the global scope is exposed now as self here. There's some other API that you might access in the web worker, which is the navigator. I do find that's quite interesting. All right, and anytime that you define now an identifier here with var or functions, it's going to be appended to this global object as well. Again, this is the behaviors. The another is the developer tools and console reps, which is again part of the something that is provided by the browser, but it doesn't behave as a true JavaScript environments, because the behavior of the global scope, all right, as well as the hosting, how these things are now host certain stuff, and the blocking scope declaration in let and constancy chapter 6 when used in the outmost scope. Although it might seem while using the scope rel that statements entering the outermost scope and being processed in the real scope, that's not quite accurate. But again, this is something that we're going to see also in today's video, which is the developer console tools. The other is the ES6 models, that when you're working now, for example, with this models, all right, which is something that we covered in chapter 8, good. This particular code, at least in ES6 models, again, you can have access to those variables, or you can expose those variables, and they behave like a top level global here via the export keyword. ESM encourage a minimization on relying on global scope. Exactly, where you import whatever models you may need for the current model to operate. Something that this is go beyond the scope of today's video, but when you have now, or when you define your user interface in React as a JavaScript function, as a JavaScript, as a ES6 model, this is what you have to do so. And the other is now node environment. So node is something that when you it is interesting because I was assumed that any time that you now run a particular JavaScript file in Node, if you import if you import files here via the CommonJS models, it will act as a single file, right? But the practical effect is that the top level of your Node program is never actually the global scope. So that way is when loading a non-model file in the browser. So all of these files that are being loaded in Node, they act as a standalone file. They don't have is the global scope. So this is why you can now, if you use a model CommonJS, you can export this model as it is. Makes a lot of sense. Exactly. You can export this model as it is. Yes, it is. You can export this model as it is. Absolutely, absolutely. Yeah, you can export this model as it is, right? Or you can think of this like exposing now a function wrapper here. But now, we also in Node, we can have access to a global called global or global this. All right. So to global this, review of the JavaScript environment we have looked so far. A program may or may not declare a global variable in the exactly. A program may or may not declare a global variable in the top level scope with var or functions declaration or let const and class, and also with another functions because this also goes beyond of that, but it's okay. It goes beyond because you can also do that with generators and async functions. Also add global variable declaration as properties of the global scope if var or function are used for the declaration. Okay, this is exactly. So depend of the environment in which JavaScript is running, it can declare a global variable in the top scope. Okay, so declare a global variable in the top of the level scope with var, functions, class, generators, let and const. Also add global variables declaration as property to the global scope if var or function are used for the declaration, and refers to the global scope object for adding or retrieving global variable as property with window self or global. In other words, you can have access for adding or retrieving global variables to this particular global objects, depend of the environments. And again, after that, all right, then we answer a question, which is, so once we recap about the scope, all right, and how the scopes are created and what the scope, what's keywords create scopes. So for example, block, functions, and catch in the try statement. Okay. We also look that interesting, especially with async and function and so on. We also look at how this actually behave in terms of identifier redeclarations, okay, and also deep dive into this particularly variables declarations. So for example, var functions and how they behave, right? So for example, var function let const and so on and so forth. Var function, or this hostable declaration, particularly the var and function, and how now they are hosted. So this is the behavior of when you define is now a functions or a var happens. But when you assign now a functions expression inside of a var, they are not hosted. Again, this is just for hostable declarations, not expressions. And there is a difference here. Declaration is anything that you now you don't assign to, and an expression is something that is describing in the JavaScript here. You can take a look at the expression. I'm not going to get into that because this is actually quite slow. Oh, it works. Expressions here, okay, and it is an assignment expression usually, all right, or something that produces now a value. Take a look at this expression. But exactly, this is now an expression statement. Exactly. Here in the statement and declaration, this is not an expression statement. Okay. So anything that doesn't start with a block or a function or async function or class or let or a square bracket, all right? So anything that doesn't start with this is now considered as expression, which is now an assignment here. So an expression is now interesting. So in the context of JavaScript here, expression statements are something that you assign to a variable. That's interesting. Again, according to this, right? According to this, you can have different. So you might have is different. You might have different assignment expression. You might have is different language and statement declarations, right? So you have is different statements, but an expression, okay, is something that but an expression is something that but an expression is a value that is assigned to. That's what it. Oh my god. Holy hell. Yeah, absolutely. Absolutely. That an expression in exactly, it's safe to say that an expression in JavaScript is it is safe to say that an expression in JavaScript is a is an assignment, is a value assigned to an identifier. That's or that produce a value. Exactly. It's either now a conditional expression, an arrow function, Is something that produce a value. Is something that produce a value. Is something that produce a value. That produce a value. Not at all. This is an assignment expression. Is any valid code that resolve to a value. Exactly. That resolve to a value. And a declaration and a declaration is a statement that introduces a new identifier into the current scope. And a statement is unit of code that perform an action or control the flow of execution. This is three key concepts here. Three concepts to actually understand the nuance of the language. So an expression is something that resolves to a value. And what our value is? The primitive and the objects. Good. So this is an expression. The declaration is a statement that introduces a new identifier in a scope. Okay? That's interesting. This is a declaration. And then a statement is a unit of code that performs an action. It's a unit of code that performs an actions or control the flows of execution. So I do think that I will leave that as it is. By now, that'll be all for this video. Take care. Bye-bye.